Here comes the most fun part, data analysis. So after collecting the data, we're gonna analyze and calculate the coefficient of restitution. And in video 1, we've go through how do we calculate coefficient, right? So basically we need H1 and H2 to put into equation 6, right? Or V1 and V2 to put into equation 1. So how do we get V1 and V2, or H1 and H2, by today's setting? Here's an example of the motion of the ball. So initially it starts here. You're gonna hold it there with certain height. It could be 1.5 meter or 1 meter. And it drops onto the force plate with V1 right before it hits the force plate. And then it's going to bounce back with V2, probably a bit smaller than V1, and then go up, up, up until it reaches the apex, and then go down again and hits the force plate again, right? So we need height 1, V1, V2, H2. That's all we need. For H1, actually, we've already given you H1, right? We're going to drop the ball from 1.5 meter or 1 meter. That's already controlled. So you've already got that number, easy. And then for V1, think about it. If you drop with higher height, how do you think the V1 will change? It'll be larger, right? If the drop height is larger, the velocity will be larger. So actually it's related to the height. And if the height is known, then we can use certain equation to calculate it. So those are the equations we need today. And the most important thing, those equations look super complicated, we're going to simplify it by making it a free-falling motion. So look at this equation. It's V final square equals to V initial square plus 2 acceleration and distance. And look at this motion. What's the V initial? 0, right? In free falling, initial velocity is 0. So there is nothing. That means Vf squared equals to 2AD. We make the equation simpler because initial is 0, Vi is 0. Then acceleration is only pulling by the gravity, right? So the acceleration is 9.8 meter per second squared. And the distance is the distance traveled by the ball before it reaches certain velocity. So the distance will be the initial height, h1, that'll be 1.5 or 1. So this equation, after removing vi and take a square root of both sides, make it simpler like this. V equals to square root 2gh. To put into here, we know v1 equals to 2gh square root, right? So it'll be 2 times 9.8 times h1. And you take a square root of it. That's v1. Easy, right?